A sociologist claims that children ages 5 through 12 spent more time watching television in 1995 than children ages 5 through 12 did in 2015. A study was conducted in 1995 of 30 children to find out how many hours per day they watched television. The population is normally distributed with a standard deviation of 0.6 hours. A study was conducted in 2015 of 30 children to find how many hours per day they watched television. The population is normally distributed with a standard deviation of 0.5 hours. At alpha equal to 0.05, can you support the sociologist claim? So both sample sizes are large enough. The claim is that mu1 is greater than mu2. Now because the claim uses a greater than sign, we know the claim is the alternative hypothesis. And we know that the test is right-tailed. The null hypothesis is mu1 is less than or equal to mu2. Alpha is 0.05. Sigma 1 is 0.6. Sigma 2 is 0.5. And this is a right-tailed test. So now let's go to the calculator. I first want to enter in all of my data into two lists. So press Stat and select Edit. And then the 1995 data I'm typing into L1, and the 2015 data I'm typing into L2. So then quit out, and then go back into the Stat menu, and go over to Tests, and select two-sample z-test. Now make sure to select Data for the input, and then type in Sigma 1 and Sigma 2, List 1 and List 2, and then specify 1 for both Frequency 1 and Frequency 2. Scroll down and select the right-tailed test, and then press Calculate. So z is equal to 2.62, and the p-value is 0.0044. So the picture looks like this, and 0.0044 is less than 0.05. So because the p-value is less than alpha, we reject the null hypothesis. And the conclusion would be, at the 0.05 level of significance, there is enough evidence to support the sociologist's claim that children spent more time watching TV in 1995 than in 2015.